Hey guys, welcome to the statistical analysis portion of your guys' treatise work. In this particular video, I want to show you guys how to make some meaningful inferences from the data that you have. In your particular study, what you guys looked at is the force data for various anatomical landmarks and to compare them for both shod and barefoot conditions. So we have a nice table over here that compares the shod and barefoot force conditions for different participants for the left and right feet. Right. So how do we start making meaningful data out of this, meaningful interpretations to see if there were significant differences between not only the participants but between the shod and barefoot conditions for the various anatomical landmarks. So that's one part of the video that we will definitely look at. The other is also to start making sense of the kinematic data. So what you guys would have got is the knee range of motion data and the hip range of motion data. And what we want to see there is there a significant difference between, again, shod and barefoot conditions in terms of how you tend to run. So first of all, I'll start with this because it's easier to run the statistics on. And in the next video, I'll run through some of the more complicated statistics. Okay, so first of all, let me just explain what it is that you guys are seeing here. So the green line represents the mean data for all 5 participants throughout the entire gait cycle, right? So the data that we have on the side here in the Y column is the range of motion, and the bottom is just the percent of the gait cycle at a specific point in time, right? The gray area denotes 1 standard deviation above and 1 standard deviation below the mean, and it shows you the where most people experienced range of motion throughout the gait cycle, right? So now what we want to try and see is how does this compare to both shod and barefoot conditions. So what we will have to do is get the knee data. In this case, this is the knee range of motion data during the barefooted trials, and this is the knee range of motion data through the shod trials. If we plot this data on the same graph, you will see here that there is some difference between the two, and where the peaks tend to occur, where the troughs tend to occur, where the secondary peak tends to occur. But are these differences significantly different from each other? So that's kind of what we're trying to establish in this particular video. So what we'll do, first of all, is create a new page, because this is where we're going to run our statistics. I will then copy and paste the knee range of motion data for the barefooted trials, and I'll paste it. And remember, this is the mean. This is the mean data for all the participants. This is the shod knee range of motion data. So I'll copy and paste that next to it. It doesn't matter at this point that they're not of equal length. That is fine, and that is to be expected. Okay, so how do we then start making a meaningful inference out of this? Well, something that you'll do is just to see what the mean and the standard deviation is, because it tells you how far or how much the data tends to vary relative to the mean. So to calculate the mean, you just type in average, highlight the data in this particular column, close bracket, press enter, and for the standard deviation, it's equal STDEV. You'll see there's different options. One's for the population, one's for the sample. We've got a sample, so we'll click that, press the tab button, and then highlight the same data. Close parentheses and press enter. And what you can do is just highlight those, click and drag across, and we'll get the values for the other column. Okay, so you can see here that there is a difference in the mean, and the standard deviation is fairly similar. So we'd expect to see that there is some spread, but the spread between these two is fairly consistent. Is it significantly different? That's what we're trying to test. So in order to do that, for two data sets that are not of equal length, or it doesn't matter if they're equal length, doesn't really matter, we run the F test. So you go to your data tab, you go to data analysis. If you don't have it, you need to install it, and I'll go through that. Let me just go through it right now quickly. Go to file, options, add-ins, click the data analysis tool pack, at the bottom here, click Go, and then select the data analysis toolpack with the tick button and press OK, and it should install it. Okay, I've already done that, so you go to your data tab, go to data analysis, and then what we'll do is run the F test to determine the variance. What we'll do is then highlight the first range, which is the knee values for the barefooted conditions, highlight the second range, which is for the shod conditions. There are labels within our columns, so that's fine, and our significance level is the alpha of 0.05. I want to output the range on the same page, so you'll just select where you want to put the data and then click OK. My apologies, I have to press that over there and press OK. Why is it? Oh, never mind. I made a mistake over here, and press enter. That should fix it. There we go. Alright, so what you'll see here is an output. There's the mean, which should be the same as our means that we already got down here. Here's our variance. Variance just tells us on average how much each data point differs from the mean within its respective columns, and then it basically tallies it all up. The standard deviation is basically just the square root of the variance, so it's basically telling us the same thing: how much on average does the data vary from the mean. And what we want to try and see is whether or not that is statistically significant. So how do we interpret that? So we have our different hypotheses, right? The null hypothesis, and I know I can already sense your eyes glaring over, but just pay attention here, because that's going to really help you make sense of it. Basically tells us that the variation or the variance between the two groups, right, is the same. Your null hypotheses on average will always tell you that. It assumes everything is the same, there's no difference between your two measurements, and our goal is to see what the probability is of that being true. The alternative hypothesis says that it is not the same. In other words, there's a difference, and whether that difference is greater or lower is something that we're trying to then establish. So what we're then interested in is this p-value, which is telling us the probability that your null hypothesis is true. So we can see here that we have a value of 0.49, which tells us that the probability that your null hypothesis is true is a whopping 49%, right? Which is a lot bigger than the 5% cutoff that we normally say to reject this thing. So it's saying that the chances that the variances are the same is 49%, therefore we accept the null hypothesis, we cannot reject it. Okay, so that's going to tell us which test to run next. So I go back to my data page. Now I'm trying to see if it's statistically significantly different from each other, and I run the t-test to do that. Since we have equal variance, I will use the t-test assuming equal variance. If this was less than 0.05, then there is unequal variance. In other words, you reject the null hypothesis in favor of the alternative hypothesis, and then you would select the unequal variances test. So I'm going to go for equal variances because that's what we've established. I will then highlight the values that I wish to compare, press enter, run this for the shod condition. I do have labels. My alpha level is still 0.05, and my output range I'm going to put just below over here, and I press OK. Good. So I get exactly the same data again in terms of means and variance. That's what the t-test states, is saying how much do the means of these two conditions differ from each other, and is that difference statistically significant? You will see that I have a one-tail and two-tail test. We, on this particular assignment, aren't concerned with which one of these is higher relative to each other. So we're not putting all our probabilities into one basket and saying that this one is higher than this one or this one's higher than that one. So we will use the two-tailed test. And what we can see here again is that if we go again by this p-value, where we say that the probability that they are the same is much greater than your 0.05. In other words, what we have here, the probability that they're the same is 56%. So therefore, this is not statistically significantly different from each other, right? So in other words, it's saying that the knee range of motion data that I have in both my barefooted and my shod trials are at least similar. They may not be exactly the same because we do have some variance and we do have some differences in the means, but these differences aren't statistically significantly different from each other. So in essence, you could say that they are the same. So what I want you guys to do is run the same statistics for your hip range of motion data and see what you get from that. Alright, so that's it for part one of your analysis. In the next one, I'll start showing you guys how to make sense of your force data. It's going to be a little bit more involved, but I'll see you on the flip side.